Welcome to part 2 of this tutorial on how to build a Computercraft controlled nuclear reactor. In the last episode we looked at how I put this thing together. We didn't look at the receipts, but how this setup is made. And before this episode I have actually cheated a bit, because I started recording making the user interface for the program to be, and as of now it looks like this, and just this took like 20 minutes, and it was this is not fun to watch at all, but I will show you the code very swiftly. The only thing you see here, which it was not in my original version, which I just wanted to have because it's easy to make, is if the MFSUs are full. To look at what I made so far, I always construct my programs like this. I always first have my variables, defining my variables, then I have my functions, and all in the end I have the body code. As you see now, it only calls one function, and that's to draw the screen. And that's all you see here. And if this scares you away, you shouldn't watch my next episodes, because this is well, only a fraction of the program to be. First there I find the size of the terminal. I'm using it for some reason. Then I have the variables for the number of nuclear reactors. Well, this one is number 1. And the nuclear state, we say unknown in the start, which temperature level it have, and if it's producing EU, if stop applied, and if MFSU is full. So the first we will have is the function to draw the screen. We clear the screen, set the cursor up in the left corner, and I made our own function draw across, which draws a character across the screen from position 1 to the end on the defined line, which I can put here. We can see that function pretty fast. It looks like this. I'm sending in the line, the character, and it set the position to start of the line, like over here, and in the defined line. Then it goes to a for loop and writes the character all the way until the end. Okay, so that's that one. And it draws basically a line in the top and draws a star in the left and star in the right side of the screen by setting the cursor in the end of the screen in line 2, and it draws across another line below that again. And then I have another function which draws any text I have centered and nothing else in line 2. I already printed in the left and the right, and it draws the text in the center without just drawing it. It looks like this. Draw centered, which line I want to type it in, and what text I want centered, and it calculates where it have to start the text. So it's like the width of the screen minus the length of the string divided by 2, and it sets the cursor position and write the text. After that, it's just a series of prints. I only use prints whenever I want a line shift. I just want to type line shift, type line shift, type line shift. I'm using prints, so you don't have to type terminal set cursor position every time and then terminal write. So I'm printing the nuclear number. This will be a static number. So if you have more than one nuclear, you can actually type the number so you know which nuclear reactor the current computer are controlling. And it's the state. As you see, all these are variables which we will control eventually, and the screen will just update itself. And like producing EU is a Boolean value, so I had to cast it into a string. Same with the stop applied and if MFSU is full. So let's get to the programming, because after we have drawn the screen, well, basically we want this now to be a while loop. So the easiest way to make this loop forever is do like this: while true, just do it until you get break eventually. So in this we want to read input. We want to read all the signals coming in, so we'll make a function to read the input. Then we'll sleep. Let's wait a second. Draw. We'll do like this. Draw screen. We'll call the function outside the loop, so it will draw the initial screen, and we'll do like this. Draw screen. Sleep. Yeah, let's say 2 seconds. 2.0. This way it will first draw the screen, it will read the input, and then it will update the screen again and sleep, and read the input, update the screen, sleep 2 seconds, all the way. This way he will always print the latest data after you have read the input. So let's make the function to read the inputs. Function read input, and this means we need a lot of new variables. Not too many. Let's take the easy ones first, because it's like MFSU. No, let's take one we actually have. It was stop applied, right? Stop applied equals, and then we want to read a certain input, so that's test bundled input on the left side. And remember what I told you about the powers, like it's 1, 2, 4, 8, 16, 32, 64. This is 64. Let's try see if we can read this and get this to be true. And yeah, 128, 256, 64. So if we read this one, okay, stop applied. So now it will read this input and return true if it's on, and false if it's off. So if you do this now, you say stop applied is true. If I now remove this one just to test it, it says false. Ah, great, we know how to do it. But there is, I just learned there is a bit easy way. Instead of remembering all those numbers, if you're not so good with binary, you can do a small shortcut. Let's see, edit nuclear. Instead of typing the number, there is actually something named colors dot, and you say pink. It's just a reference to the number 64, so you don't have to remember the numbers. So this will actually do exactly the same. It says stop is applied is true. You do this, you'll get this false. And do this, and you get this true again. Dang, it updates fast. Maybe this will be better than the first one I had. Okay, so we got one signal working. Wow, that was fast. Now let's read all the other inputs. Let's see. Edit nuclear. We need some other temp level 0 equals false. This will be the different what's it called, remote thermal monitors. False, because I will read the variables into these. So the 0 will be the lowest one, so I need 5 of these. Temp level hello kitty. Kitty wants to play. Level 4. And yeah, and I think I'll cheat a bit like this. Not cheat, okay? So this will be the first one there, and the second, third, fourth, fifth. So we'll just read them into those variables, so we can work with the variables instead of calling up that redstone function every time. And we will also have to read this one, and this one. Makes a total of 8 inputs we have to read. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have to read all the 8 inputs into these. So let's get started. And since I find this easier, temp level 1 equals what was the test? Lead input from the left side. I know it's 1. I find it easier than finding the color, because I know it's in the right order. Temp level. Now there's just all this typing. Rest test lead input. Test on left side, and the next one is 2. Temp level 3 equals redstone. Test bundled input. It's still on the left side, and this time it's 4. Temp level 4 equals redstone. Test bundled input. And if I sound weird, it's because I'm Norwegian. Temp level. Did I mention that I play on Computercraft? Come play with me. Input. Jesus, I can't talk while typing. Okay, so 16. As you see, it's the basic system is this number times 2. It's this number times 2. This number times 2. This number times 2. It's actually pretty easy. Okay, so what was the next? This transmit signal, so we're not interested in reading it, but this one was the 64. 64 was the stop applied. Okay. Just to make it look the same. The next was producing EU equals redstone. Test bundled input left. It was 128. And MFSU full equals redstone bundled input left. Nah, this is wrong, but I'll correct it. 256. Yes, test. I need to test it. Okay, test bundled input left 256. Okay, we can test a few of these. Not all at the moment. Let's test these 3. Nuclear. Okay, MSU of full. Let's trigger that one again. What we did, simulate it's empty. It would say it's full. Yes, it's full. Great, it's working. And the next thing was this one's producing EU. Producing EU is false. Turn on the reactor, and it's producing EU. Yay! Now these got power as well. I think it heated up quite fast. I mean, dang, 500 degrees. Isn't it dispersing any of the heat? Okay, so we have read all the signals. We haven't tested these yet, because the next thing we will do. Hello, Batty. Batty. I don't know if you can see anything. It is on bright, but I can make it day like this. Okay, so the next thing we will do, we'll make the code which figure out which temperature level it is in. So basically, if none of these are active, we will say this is temperature level 0. If this one have reached, we'll say temperature level 1. If this one have reached, is level 2, level 3, 4, and 5. If the temperature is above this one. Okay. Edit nuclear. How much time have I used so far? Jesus, 15 minutes already. I mean, you see where the time disappears. Maybe I have to make it a long one. Okay, read inputs. Let's read temperature level. No. Temp level. Let's make a function for that as well. Function read temp level. So this will just be a series of if cases. Okay, so first let's make the temp level 0. If not temp level 1 or temp, oh, this will be long, 2 or temp level 3. It's the reason why I shorted down the temp word. Or temp level 4 or temp level 5, then temp level equals 0. Else if here comes the fun. Temp level else if temp level 1, then maybe this won't be so complicated anyways. I do simplify this code quite a lot. It does not catch anything, all things, because no, this will not work. I have to do it in opposite. Because if it's, I have to check on the highest first to make it work on the stupid way. If as if temp level, and I of course have to use equal. No. Temp level, because this will always be true or false. Temp level equals 4. Else if temp level 3, then temp level equals 3. Else if temp level, yes kitty, I know you want to play. Temp level equals 2, almost there. Else if temp level 1, then temp level, my oh my, equals 1. And I need another and. So I believe this will work, because the first if one of the sensors are high, it will actually not be true, and it will not be temperature level 0, and it will first check, are you temperature level 5? I'm 5, okay, and if it is 5, it will just skip the rest. If it's 4, it will say I'm 4 and skip the rest. If it's 3, I'm 3, I'm skip. So it will always just check for the highest temperature level there is. So if you do this, edit, no, nuclear, clear, line 60. I do not code perfect, and this might be a quite inefficient program, but this is how I solve it. Let's see, temp level 1, temp level 2, temp level 3, temp level 4, there we have it, or temp level 5, nuclear. So it says temp level 0, and that would be true because none of these receives power. Let's I don't want to fire up the nuclear reactor, and this is why I made this one. Okay, so now when all are high, it should say temperature level 5. Great. And if I increase this by, say, 3000, how hot is the reactor? Okay. And temp. Thermal. I need to measure the temperature. Okay, 4008. What's it called, this cooling things? Wasn't it? Ice. Ice works, right? No. What is it called then? Cool. 60k coolant, 30k. Okay, let's try this. I don't know how this works anymore. Hello? Screw that. I can test this and find out until the next time, because there was like 4,800. Okay, so now it's 5,500. It will be level 4. And if we do the same, I take this to 5,500. This is not true. It will go to temperature level 3. Thing is, if this goes back and is high again, it will just ignore this one and assume this is the highest and go to temperature level 5. Yeah, it is. And this one will take it to level 0, 1, 2, 3, 2. Level 2. And this to level 1. Yes. And when this is high enough, it will go to level 0. Great. So we got this one working, this one working, this one working, and this one working. Okay. This is actually going much faster than I was expecting, considering I used like probably 3 hours on this the first time I made this. Now I did it in like 20 minutes, plus 20 minutes in the user interface. And so I think this will be it for, we have now made a program. It's not much, but it takes time. We have now made a program to read all the sensors. Basically, that was what we did. We read the input and we made a code to actually make a temperature level out of the numbers, and we will use those numbers in the main code, which actually controls it. So it reads inputs, it reads the temperature level, and then draws the screen, sleeps for 2 seconds, and then it updates itself. So in the next episode, we will start making the system which controls the nuclear reactor, which will be the most fun part, and we get to start this one, and I have to find out how to cool down the nuclear reactor. Apparently a lot of it's changed. I don't remember what it was named even. I thought it was dispersers or something. Disp. No, I'll find it until next time. So thank you for watching. I hope you enjoyed, and watch part 1, watch part 2. Part 3 will be out pretty soon as well, I guess. So a like would be quite fun as always, and see you next time. Then we will have what will start the cooling if temp level is greater or equal to 3, then cooling equals true. So this means if it's temperature level 1, 2, 3, if it's greater or equal to this, it will actually turn on the cooling, which will turn off the reactor. Okay,